Hello, I'm Daniele Di Mauro and I'm presenting the work on supervised domain adaptation for 6 degrees of freedom indoor localization. Wearable devices equipped with a camera can be used in a cultural site to develop user-centered application able to provide information on where the visitor is located. Since collecting and labeling large datasets of real images is costly and time-consuming, we investigate whether the use of synthetic images can be useful to achieve good localization performance on real data. The cultural site where we collected the data is the Bellomo Palace Regional Gallery. The museum houses a collection of Sicilian art from Syracuse and from the region. The most famous item is a painting by Antonino da Messina. The acquired dataset is composed by 4 rooms. Each room has been scanned using a 3D scanner and visited with GoPro headset. Simulated images are labeled by design. To label real images, we reconstructed each room using the structure from motion software Colmap, and then we aligned the model and the scanned one. In this slide, we can see the different kind of art item present in the museum, and the difference in light and texture between real and synthetic data. The proposed method is a network which is trained end-to-end. The network has 2 branches. The regression branches is designed to predict the camera pose directly from the input image. It's composed of an attention module and a regression head. The self-supervised branch introduces an auxiliary task which can be performed on both domains simultaneously, encouraging the learned feature to be consistent across domains. We considered 2 different self-supervised tasks: the classification of an affine transformation applied to the image and the detection of the presence of an overlap between a pair of images. The compared methods are vote and verify, which is a shift-based image retrieval approach implemented in the Colmap software, the postnet approach to localization, tuna-if domain adaptation method based on CycleGAN, ADA, a domain adaptation method which focuses on feature adaptation, and Cicada, a domain adaptation method which focuses on adaptation on both features and input data. In these 2 tables, we show our baseline, obtained training and testing methods on single domain with supervision. The first table reports results on real data, while the second reports results on simulated data. In the table, we show average position error, average quaternion error, and average Euler angle error. We can see that the best results with supervision are obtained using the classic image retrieval technique methods. In this table, we show the domain adaptation results. Both ADA and Cicada approaches fail to solve the problem in this formulation. Our methods reduce the position error by 44% in the best test in comparison to postnet, and reduce the error by 6% in comparison to style transfer at training time. It's worth to note that our method is faster at training time. In this work, we have proposed the new problem of supervised domain adaptation for 6 degrees of freedom localization. We collected a new dataset in a cultural site which is available online. We have introduced a method to exploit the synthetic data to learn to regress pose in indoor environments. Results show that the problem is still open. In particular, the result of absolute pose estimation are still underperforming compared to classical image retrieval approaches, and domain adaptation approaches are accordingly affected by this.